Welcome to MyProjectBazaar.com. The title of the project is Identification of Apple Leaf Diseases based on Deep Convolutional Neural Network. And the abstract of the project is leaf disease are not only influence the economic importance of the fruit and its product, but also abate their ecological prominence. Apple fruit, especially the fruits and the leaves, are highly affected by the fungal disease named as Anthracnose. The main aim of this process is to develop an appropriate and effective method for diagnosis of the disease, espousing a suitable system for an early and cost-effective solution of this problem. Over the last few years, due to the higher performance capability in terms of computation and accuracy, computer vision and deep learning methodologies have gained popularity in assorted fungal disease classification. Apple is widely cultivated as a kind of leaf. In the whole growth cycles of apple, there are many types of apple leaf diseases and pests. Therefore, the detection and diagnosis of this disease are very necessary. The deep learning algorithm by convolutional neural network algorithm are used to predict the disease from the apple leaf. In this process, deep learning is used to reduce the size of the training data, the time and the computational cost when building deep learning. Dataset contains both healthy and infected apple leaf images. Result envisage the higher classification accuracy of the proposed CNN model. The result will be generated in the form of accuracy, precision, recall, and F1 score. And the flow diagram of the project is: first we need to start the program and select the apple leaf disease image dataset, and then we use the sample dataset in the console working directory. Then it will move into data pre-processing. In data pre-processing, we are going to check the minimum height and maximum height and minimum width and maximum width for every classes from the apple leaf disease dataset. After that, we need to visualize the sample images from all the directory. Then it will move into feature selection. Before that, in pre-processing, we are going to resize all the images and convert the images into array. After that, in feature selection, we need to select the independent variable and dependent variable. After selecting independent and dependent variable, we are going to split the dataset into training dataset and testing dataset. Then it will process it into classification. In classification, we are using convolutional neural network deep learning algorithm to classify all the apple leaf images and predict the type of disease. Then it will finally generate the result in the form of metrics like accuracy, precision, recall, and F1 score. The program was successfully executed in Anaconda Navigator Spider ID, and this is the sample image visualization of our apple leaf disease images. And after that, I have to check the minimum height and minimum width, maximum height and maximum width for every classes from our dataset images. So after that, I have to set, and this is the binary segmented result, and this is the k-means cluster segmentation result. After that, I have to label our classes into 0 to 3 because I have 4 different types of diseased classes. And after this is the k-means cluster segmentation result, and this is the mask of the k-means cluster segmentation. This is the sample images from our input data, and this is the independent variable train data, independent variable test data, and this is dependent variable train data, and this is dependent variable test data. After that, I have to apply our input to our convolutional neural network algorithm, and these are all the summary result of convolutional neural network algorithm. And the convolutional neural network algorithm extract the overall parameter. Trainable parameter is 9,26,788. So these are all the parameters are in trainable form. So our input images will train based on the parameter in for the 25 different training epoch, and it will generate the result is 99.96%. And this is the performance graph of convolutional neural network algorithm, and this is the classification report for convolutional neural network algorithm. In that, it will generate the precision, recall, and F1 score results. And precision means number of correct prediction, recall means number of correct instance of prediction, and F1 score means to measure the test accuracy. And this is the confusion matrix. The confusion matrix, which is going to explain the number of correct prediction and number of misclassification from the every classes in our dataset based on the convolutional neural network algorithm. Finally, the user can manually choose some images from our dataset directory, and our algorithm going to predict the exact classes for the input images. And this is the variable result that we are using in our program.